so let me fill it. So, class. Thank you. Okay. Okay, when you guys actually watch the video, can you hear the class going yes sometimes? Yes! I made Tree scream one time because he would not say anything. Anyway, alright, so we're going to go through and same rule, but right now we're starting with this thing right here, which is currently sitting at a special type of notation. Anyone recall the DDX? What is that, the? Leibniz. Gottfried Leibniz, the inventor of calculus. Not the other guy. Okay? He invented it first. The other guy actually just like didn't really steal his credit, but denied him credit, and since he was more popular, Leibniz didn't get the credit for it. I know, right? Anyway, so I'm going to rewrite this right here. And so this is, I'm basically taking the function here, and I'm taking the derivative of the function in terms of x. So sometimes you're going to have different variables, like on the second one. I'm going to take the derivative of the function in terms of u. There's my du. The third one, taking the derivative in terms of s. Yes. Say one more time. There, okay, right here. This is, you're just taking of this expression. It's not a function, it's an expression. If you had the function y, you would have a dy dx. And that is taking the function y, because sometimes you're going to have a function, you know, x, y, z, okay, or y and s and t and v. So a bunch of different ones would go here, because sometimes we're going to have different functions going together. So up here is where that goes. So dy dx. Does that make better sense? Okay. So that goes with the name. The bottom goes with what I am taking the derivative of. This is in the proper notation. So what do I do with my exponent? The exponent goes where? Out front, right? So it's a -1 times what's in front of that exponent. So it's 1. So that's just going to give me -1x. But what do I do to my exponent? I take away 1, right? I subtract 1. So that is going to give me -2. Now, can I rewrite this? Because a lot of times they ask you to rewrite it with no negative variables. Negative exponents. No negative exponents. There we go. Okay. So I'm going to rewrite this. So this is going to give me -1 over x, and as it moves across the divisor, it changes signs. So it goes from a -2 to a +2. Ba-da-ba-ba-ba. No one's loving it? Damn it. Okay. Now, I'm going to mess up this next one. I'm going to mess it up because I don't like it the way it is right there. Because I don't like this down here in the denominator. So I'm going to move it up to the numerator. So I'm going to rewrite it first. So I'm going to say that du of u to the -2. Because all my voodoo magic that I know has to do with this being in the numerator. Yeah? Okay. So I could do the voodoo. Let's do the voodoo. So what are we going to have out front? -2, right? U, and what am I going to do to that -2? -1, so that's going to give me -3. And then I do my rewriting. After I do my voodoo, I do my rewriting, so that is my answer is a -2 raised to the u to the 3rd power. Yes. All right, let's mess up this one. So if I mess this one up, I'm going to say that d ds, and that is going to be 4, bring this up, s to the negative 5. Now, for clarity's sake, my 5s have a hat on top, okay? I clearly lift up my writing utensil and make a straight line. So I do my best to overdo my s's. So when you see an s and a 5 together, so because we're going to do a lot of those when we're talking about position, velocity, acceleration, all that other stuff. So yes, so my penmanship, I'm sorry, I've been working on it for close to 50 years and it still hasn't gotten better. Actually, this is pretty good compared to what I used to have. Anyway, let's go ahead. So what is my derivative, doing the voodoo magic? Negative 20 s to the negative 6. And then rewrite it. So negative 20 s to the positive 6. So, like I said, I'm working on my penmanship still, and if there is something that you cannot make out, please say something. I don't want you to get confused just because you can't see my handwriting very well. Are we good? All right, let's keep going then. Higher order derivatives of a power function. Find the second, third, and fourth derivatives of this. Okay. So I'm just starting off with a y equals. This one's not in velocity and all that other stuff. It's not a movement one. So my function is y equals 2x to the third. So when I take the derivative, I turn it into a y prime. Voodoo this one, I get 6x. Very good. All right, so now we are going to take the next derivative. So there's the first derivative. Here's the second. Y double prime is 12x. Okay. First, second, third derivative. So y 1, 2, 3 is going to give me 12. And then fourth derivative, so that's going to be y 1, 2, 3, 4 is going to be 0. They all have uses. They do. Is that pretty easy though? Now, Leibniz, say it again. Leibniz notation is just super weird once you're actually getting this level of craziness. Okay, you put exponents in there, so it's going to look weird when we do implicit differentiation with it, but the Leibniz notation is a lot easier than this when we do implicit. Second and third derivatives of this. Ooh. Now, first, I'm going to write my function y equals Did we already do this one? Say yes. What rule is this? Is this two things being multiplied together? Yes, it is two things being multiplied together. Because this here, that 1 plus x squared, is one term right there. And it's this right here even if I was to distribute, I have an x squared times an e to the x. That is a product that is being multiplied together. So I have two x's in the same part. So as a product rule, we did this one a couple slides ago. Would you like for me to do this one again? Yes? Okay. So I'm going to say that my f is the first part, 1 plus x squared. G is the second part, e to the x. F prime is going to give me 2x. G prime is e to the x. You don't remember this, Christian? Because I called you on this one right here. I was like, hey, what's the derivative? E to the x, yeah. Okay. All right, so now product rule says that I am going to have f prime g plus g prime f. So the product rule has a plus sign, quotient rule has a minus sign. That's a good thing to actually start trying to get in your head on this one. Because to remember these, it's going to make your life a whole lot easier. So let's go ahead and do this. So it's f prime, so that's 2x times g, which is e to the x, plus g prime, which is e to the x, times f, which is 1 plus x squared. That's a 1, not it. My board has like some weird wonkiness right in here. I get some like dead cells right in there. Now, I'm going to leave it like this. I'm going to leave it just like this. So now we're going to take the second derivative of this. Yes, that guy.
Would that be the answer for the free response? Or
I almost understood.
would
So
that be the answer for the free response? Just leave it like that? Would that be okay?
we haven't actually made it that far yet.
Oh, okay.
This is the first derivative. This is the one that we did the other day. So I just wanted to go over this again, all the steps. So this right here is my first derivative. So this is my y prime, right? So yeah, if that's what I was looking for, leave it alone. I'm looking for the second derivative though. Now, let's see if you guys could actually see the magic going on here. Do you recognize this? Is that my original problem? That's the original problem, right? But the first derivative has the second one in it, doesn't it? That happens a lot when we have e to the x's. So, do I have to go through and do the product rule again for that one? No. So when I'm looking for the second derivative, so y double prime, I don't have to redo that. Could I just actually state that again? Because the derivative of just this portion right here is going to be 2x e to the x plus e to the x times 1 plus x squared, close. So that right there is the derivative of just the red piece. But there's a plus sign right here, so that means I also have to take the derivative of this. This is a product rule again. I can't just, throw it down. It's a product rule. It's my 2x times e to the x. So that again in itself is another product rule. So I'm going to go to the next page and I'm going to do this piece right here. Same steps like I did. Two x e to the x. So if I say f is my 2x, g is my e to the x, f prime is 2, g prime is e to the x. So I'm going to do it again. So f prime g plus g prime f. Just putting these together. 2 times g. I don't need that parentheses. Plus g prime times f.
Is that just for f prime, or is that just a 2? Is that 2 for that?
That's a 2. Yeah, like I said, my board doesn't like certain parts over here, so it's like doing like this weird thing where it's like a dead cell on the thing. So, are we okay with this piece right here? I'm going to carry this piece back to my other problem and put them all together. So 2 e to the x plus e to the x times 2x. Could I rewrite this one with the 2x first? Say yes. Okay. Was it just 2 e to the x? Okay, so now plus sign, all this other stuff over here. Now, AP question. What do I do with that? If this is a free response, what do I do with that? Leave it alone, right? Because we did every single part correctly, combining like terms and actually going from there. That would be a place in which that you could make a mistake. A lot of people, and that's the reason why they have this rule, you could take the derivatives, you could do the second derivatives. The place where you make mistakes is little additions and subtractions. So, I would leave this alone, but do I have to find the third derivative? Okay, so I would submit this as my answer for my second derivative, but to make my life easier, I am going to combine like terms. How many like terms do I have to combine? I got 2x e to the x and 2x e to the x, right? Yeah? So that together is going to give me, so my y double prime is 2 e to the x plus 4x e to the x plus 2, not 2, back it up, plus e to the x 1 plus x squared. Like I said, when we have an e to the x, quite often, that's going to keep repeating. When I do this, it's going to repeat over and over again. I'm going to have a lot of same things. So when we take the next derivative, because we have to find the third derivative on this one, this piece is still the same again, right? This next piece over here, slightly different, right? That's just 4x e to the x. That's looking a whole lot like what my last one was, right? And this one right here, does this one have another x in it? This is just an e to the x. There's no second x. So if there's no second x, I don't have product rule. Since that's not going to be a product rule, I just take the derivative of that. What is the derivative of e to the x? It's e to the x, right? Times what's out front, which is 2x. So, my y triple prime is going to be, this is 2 e to the x plus the red, isn't that from my first derivative? That's my original one right there, right? So when I take a derivative of that, I just get all of this again, right? So I'm going to rewrite that from red, which was 2x e to the x plus e to the x, parentheses, 1 plus x squared. Actually, let me change up this color right here, because I still have to do this one here. I still have to do that one. So yes, these problems, as I'm getting to the second, third derivatives, they get kind of long. So let's go on to a new page and do the product rule of 4x e to the x. So my f is 4x, g is e to the x, f prime is 4, g prime is e to the x. So as I plugged it in, f prime, g plus g prime, f. So I could rewrite that as 4e to the x plus 4x e to the x. And I'm going to bring this back over. This is the last little part. And back to the purple color. If I'm submitting my answer, I would just say, bam, done. But if I had to continue with it, because this is a multiple choice answer, and it's usually combining like terms, simplifying, all that other stuff. So on a free response, you leave it alone like this. On a multiple choice, your answer is probably not going to look like this. So you're going to combine it together, and let's see. Okay, so I'm going to combine. So I could combine my 2 e to the x and 4 e to the x. So my y triple prime still is going to be 6 e to the x, my 2x e to the x, and my 4x e to the x is going to be plus 6x e to the x, and then bring down my other one, which is plus e to the x 1 plus x squared. So I hate cramming stuff in the bottom of the screen, but I wanted to have all those on one page so we could see my first derivative, second derivative, and third derivative all combined together.
Why is it that from what is second derivative, it's 2 e to the x, but then when you go down to third derivative, it's plus e to the x.
Which one are you? Are you this one right here?
Yeah.
2 e to the x. What's the derivative of e to the x? E to the x, right? So it's 2 times the derivative. So it's just 2 e to the x. Does that make sense or no?
But I thought you had to take the derivative of the 2.
No, this is times. So this is just a multiplying. There's a constant right there times the derivative. So yes, these higher orders look pretty ugly. I highly recommend, especially on homework, leave room for these problems. Okay, don't be that person that has to cram everything into a single line. Yes, I'm looking at you, okay? I know, but you need to show process of getting to that point. Make sense? Yeah, showing process is part of it. Are you guys almost done? Okay, I think we're waiting on Vincent. Where are you at, Vincent? Did you get it? Okay. Alright, so
Could you go back to that one, the for X to X?
this one?
Yeah, I didn't think of that.
Okay. Okay. Alright, acceleration. And let's save this one for tomorrow. So we'll do the acceleration, which we did talk about a little bit, but this time we're actually have it in full notation and everything. A is the acceleration of t, so it's the derivative of the velocity over time. So different ways of showing it. So other than that, we will pick this up tomorrow. We'll finish it off. And then homework is gonna be 2 days after break. So it's gonna be Tuesday after break. So you could have your time over break if you want to work on it. You don't have to, because most people don't do crap over break. Alright,